In this lesson, the student will be able to take notes using vocabulary such as paraphrase, verbatim, abbreviation, and Cornell Notes. Also, I'm going to teach another word, and that's to synthesize. Synthesize. We're going to paraphrase our paraphrases. So, first let me define those words. When we paraphrase something, we take the information that we have and we rewrite it and maybe condense it and group it. So we don't write things down exactly like we read them. We shorten them and we can abbreviate them. When we paraphrase, we're putting the author's words into our own words. When we write things down verbatim, we're writing it down exactly the way the author did. Now, if I wrote down exactly what the author wrote all the time, I would end up with a book this thick at the end of the year full of notes. No, we're going to condense it down. We're going to make it smaller. We're not going to write it verbatim all the time. Hardly ever. In fact, we're going to use abbreviations whenever possible. An abbreviation is shortening a word, like miscellaneous, down to MISC. We're going to use Cornell Notes. Now I'm going to show you how to make Cornell Notes. On most papers, there's a red line. And you should make your Cornell Notes kind of like that, where there's a line that goes down the page. It's pretty simple. And then two other lines. One across the top, about that far, and another one about the same at the bottom. It doesn't matter if you don't get it perfect. But Cornell Notes are mainly taken here. And this is where our title will go. Over here is where we will summarize our main notes, and then down here we'll summarize our summary. So we are synthesizing. We are taking all of this text and then rewriting it so that it's smaller and it takes up less space, but it still has a lot of the same information. And then we're going to take some of this and put it over here so that we can get an idea of what is in this main group. If we want to review, we can go to our full notes, or we can go to our summary notes, or we can go to our summation here. Okay, I'm going to take notes from pages 10 to 17, just like we did. Now, the first thing that I want to do is I want to look at the chapter. I want to look at it and see the way it's organized in the pictures and stuff. So the chapter name is Earth's Interior. So, Earth's Interior. And that's what my notes are going to be about. And then today's date. So this is 9/09/2020. That helps me remember when I wrote it. Then I'm going to look at the main topics here. How do geologists learn about Earth's interior? What are the features of Earth's crust, mantle, and core? Looking at the main topics. That's it. So there's how do we know what we know? How do geologists learn about Earth's interior? And what do we know about Earth's interior? So, some things to know about notes. You've taken notes or made lists to help you remember in the past, and you've read and answered these questions. So this is calling back to some things that you've already done. You've already read this, and you've already taken lists in the past. You can use this strategy of taking notes whenever you read a textbook for knowledge about content. Okay? Taking notes is like expanding your brain. I can't keep all this in my head at first. I need to write it down and work with it on paper. We put it on paper until we can get it all into our mind. You'll take notes in other subjects too. You'll take notes in social studies and in English class, often in math too. Now, there are two topics here. How do geologists learn about Earth's interior, and what are the features of Earth's crust, mantle, and core? So, how do geologists learn about Earth's interior? So that's going to be our evidence. So geologists' evidence. And I'm going to read about it. And then this talks about Dr. Samuel Mukaska, a geochemist, and he looks for elements that occur only in very small amounts. So these elements can offer signs of processing near the boundary between Earth's crust. So how do geologists learn about Earth's interior? This book makes it simple. They put this key symbol here whenever there's something that we need to pay attention to. In addition, all authors repeat things, and when they repeat it, we are definitely going to write it down. Processes that affect Earth's surface are often results of what's going on inside the Earth. But what's inside the Earth? This question is very difficult to answer because geologists are unable to see deep in the Earth. But geologists have found other methods to study the interior of the Earth. Now, I am not going to write that down. That would be a mistake to write all that down. I don't want to write that down. That is just the precursor. That's just telling us what's going to happen. Now we're going to get some key information. And this book makes it simple because there is a key. Geologists have used two main types of evidence to learn about Earth's interior: direct evidence from rock samples and indirect evidence from seismic waves. Geologist evidence, two types. Now, when I take notes, I don't have to make complete sentences, and I don't have to write complete words even. I can use abbreviations. So there are two ways. And I'm going to put, now, one thing that you might want to do when you take notes is to leave some space. Whenever you have a new idea, leave a space. So two types. So there's one type, and it's direct evidence, rock samples, now the equal sign, I can use symbols. I can use symbols as abbreviations. So my direct evidence for geology, for Earth's interior, is rock samples. And indirect evidence is seismic waves. All right, now I'm going to get a little bit more about rock samples. Geologists have drilled holes as deep as 12.3 kilometers into the Earth. The drills bring up samples of rock. The rocks give geologists clues about Earth's structure and conditions deep inside the Earth, where the rocks formed. Additionally, so rock samples from deep in the Earth. They dug 12.3 kilometers. Okay, again, here's a symbol, K, for kilometers. In addition, volcanoes sometimes blast rock to the surface from depths of more than 100 kilometers. So, and rocks from volcanoes from 100 kilometers deep. These rocks provide more information about Earth's interior. Also, in laboratories, geologists have recreated conditions inside Earth to see how rocks behave. For instance, they focus laser beams on pieces of rock while squeezing the rock with a great force. Okay, so the direct evidence was rock samples. Indirect evidence is seismic waves. Evidence from seismic waves. Look, here they've highlighted the word seismic waves and told us how to say it. Seismic waves. To study Earth's interior, geologists use an indirect method. When earthquakes occur, they produce seismic waves. Geologists record the seismic waves and study how they travel through the Earth. Seismic waves travel through the Earth. The speed of the seismic waves and the paths they take give geologists clues about the structure of the planet. That is, the paths the seismic waves reveal areas inside the Earth where the makeup or form of material changes. So I'm going to key in on that. I'm probably going to write those words exactly. The paths of seismic waves reveal areas inside the Earth. The paths, seismic waves, reveal what's in the Earth. To better understand how seismic waves can reveal Earth's interior, look at how the paths of ocean waves reveal the island shown here. This is a picture of waves from above, and this is an island. And the waves break on the island and then wrap around it. Waves, figure one. So whenever they have a diagram, we might have a diagram. So I can have a diagram that shows something, because a picture is worth 1,000 words, right? I can show seismic waves deforming around an object. So there's my seismic waves. Draw a quick sketch. That's going to help you out. A diagram can help you. Geologists have found that the paths of seismic waves change when the waves reach specific depths inside the Earth. What can you infer about Earth's structure from this observation? So seismic waves change shape. They change shape when they come upon something new. has something different. Okay? That's how I take notes from that page. I'm going to leave a little space now, because what are the features of Earth's crust, mantle, and core? Okay, before I go and do that, I'm going to summarize this. So, rock samples and seismic waves, and I don't have to use the lines, and seismic waves tell us about the Earth's interior. So I've summarized this. I've rewritten all of this page into this much notes, and then I've summarized it here. Okay, so I've got some spaces in my notes. I've drawn a picture that can help me. Should I write everything down? No, I shouldn't write everything down. Can I draw a picture that simplifies the ideas? Can a diagram replace many words? Did you notice any repetition here? How many times did the author say the same thing? So they said it here once. Geologists have used two main types of evidence. Then they said it here, two main types of evidence. So when you see repetition, you want to make sure to write that down. That's the author's main point. Okay, I should be writing this in my science notebook, and I would be, but I'm making a video, so it's easier just to use pieces of paper for the video. I want you to write this in your notes. Okay, now I'm going to do the same thing. I'm going to draw my lines for the next page. And the main topic is, what are the features of Earth's crust, mantle, and core? So, features of crust, mantle, and core. And then today's date is 9/09/2020. Okay. Here are 3 keys on the page. So 1, 2, 3. And so I'm going to make sure to get those ideas. Okay. Today, scientists know that Earth's interior is made up of 3 main layers. Each of Earth's layers covers the layers beneath it, much like the layers of an onion. The 3 main layers of Earth are the crust, mantle, and the core. These layers vary greatly in size, composition, temperature, and pressure. So I'm going to write that down. 3 layers: crust, mantle, and core. They're different. I'm continuing on with the bolded part. They're different in size, composition, temperature, and pressure. Now, should I write down exactly the same words that the author used? No, I should paraphrase. I changed it a little bit. All right. Although each layer of Earth has its own characteristics, some properties apply throughout all of Earth. For example, the deeper inside the Earth, the greater the mass of the rock that is pressing down from above. Pressure, now there's a bolded word. Pressure results from a force pressing on an area. I'm just going to write that down verbatim. Verbatim means that I write it down exactly like the author said. Pressure results from a force pressing on an area. I made a mistake. Not a big one, but I didn't leave any room here. You want to leave spaces in your notes. You want to do that. Because of the weight of the rock above, pressure inside Earth increases with depth. So the pressure from Earth, the pressure comes from having rocks on top of rocks. So imagine if you had rocks piled on top of you. You would get squished. That's what they're talking about. The deeper down inside the Earth, the greater the pressure. The deeper inside Earth, greater pressure. Pressure inside the Earth increases much like pressure in the swimming pool increases. That does happen. When you go down into a swimming pool, you have to clear your ears if you go deeper. The mass of rock that presses down from above affects the temperature inside the Earth. The temperature inside the Earth increases as depth increases. So I'm going to write it just the same way, but I'm going to change the word to temperature. because I'm paraphrasing. I'm writing it differently. I'm writing the same ideas, but I'm writing it differently. The deeper inside Earth, higher temperature. Okay. Now I'm going to draw a line to indicate a new idea or a new section, because this is a new section here. And now I'm going to write down about the crust. The crust. In the summer, you might climb a mountain or hike down in a shaded valley. During each of these activities, you are interacting with Earth's crust, the layer of rock that forms Earth's outer skin. Here's the key. The crust is a layer of solid rock that includes both dry land and the ocean floor. Includes both dry land and the ocean floor. Now, notice how my notes look. Do they look like one big paragraph? No, they don't. They look like you can see the grouping of ideas. Okay? The crust is much thinner than the layer that lies beneath it. It's thin. In most places, the crust is between 5 and 40 kilometers thick. It is thickest under highest mountains, where it can be as thick as 80 kilometers. So it's 5 to 80 kilometers. The crust that lies beneath the ocean is called oceanic crust. The composition of oceanic crust is nearly constant. Its overall composition is much like basalt, with small amounts of ocean sediment on top. Basalt is a dark, fine-grained rock. Ocean crust is basalt. Fine-grained. Continental crust, the crust that forms the continents, contain many types of rocks. So unlike oceanic crust, its composition varies greatly. But overall, the composition of continental crust is much like granite. Granite is a rock that usually is a light color and has coarse grains. Both granite and basalt have more oxygen and silicon than they have other elements. Okay, so continental crust is like granite, and it is coarse-grained. Okay, now I'm going to synthesize these notes. I'm going to paraphrase them to here. So, crust, mantle, and core, different in size, composition, and temperature. Then it talks about pressure and deeper inside the Earth, higher pressure, higher temperature, and the crust includes both dry land. So, up here, crust, mantle, and core. Deeper, more pressure, higher temperature. And I'm going to abbreviate the word temperature. Temp, higher temp. Then here, it talks about the crust includes both dry land and the ocean floor. The crust is oceanic crust, which is basalt, and continental crust, which is granite. So, crust is basalt, oceanic, and granite, continental. Okay, and then I'm going to summarize the page here. I'm going to summarize the page here. The Earth has a crust, mantle, and core, and the crust has oceanic and continental crust. Okay. Now I've taken these notes from these pages, and now it's your turn. There are still 2 pages left for you to take notes. Notice that for one page here, I've taken about a page of notes. And then for one page here, I've got about a page of notes. And it's not all grouped up. I didn't write everything down. And so now it's your turn. I want you to take notes on the mantle and the core and the magnetic field.